Okay, so this is very similar to what we did earlier with the acid-base properties of salts. And in order to be able to do this okay, you really need to know what things are your strong acids and which things are your strong base. And for that, if you're having a little bit of trouble, go back to solubility rules. And if you watch that, you remember one strong cal bear, and that's the group ones, and group twos, calcium, strontium, barium. Those are all strong bases. And then CBS pin is the strong acids. If you don't know what I'm talking about, I encourage you to look back. But that's important because we're looking at, whenever we're breaking apart salts, which are essentially ionic compounds, we want to break apart the two things right here, the Cr and the I, and we want to know what they're conjugates of. Because if something's the conjugate of a strong base or an acid, it itself is a conjugate pathetic. So I'm going to start off here with something because with the CRI, and I'm going to show you a little bit of a trick here, but we have CR and we have I minus, right? This is CR3 plus and this is I minus. The trick is put an H in front of your anion and put an OH on the back end of this. And so if we do that, if we put an H in front of this, that, my friends, is a strong acid. What does that mean for us then? That means that this right here is a pathetic base, which means that the I minus is not going to contribute at all to whether or not something is acidic or basic. On the other hand, Cr3 plus, if we put it together with OH minus, we'll realize that that would be a weak base, which means that this is going to be a weak acid. Another way of doing this, so that means that this here, this part is going to be acidic, and this part right here is going to be neutral. So what does that mean if you have one part that's acidic and the other part that's neutral? It means overall you're going to be acidic. Another way of doing this, and this is actually probably a little bit better, is that anytime you have transition metals at the front of something, those are always going to be weak acids. And if you ever have group 1 or cal strong bears, again, watch the video, those will always be conjugates of a strong base, which mean them they are weak, they are nothing acids. So any transition metals, we automatically think that they're acid. Let's go down to the next ones here, and this kind of applies. If we take a look at Na and OH, well, straight up, OH is a strong is a base, right? And then we have Na in front of it. So there's no other way than this can be anything other than basic. So this is really them throwing in a base and saying, hey, is this acidic or basic? But let's take a look at NaBr. If you take a look at NaBr, that's Na plus and Br minus. This is not a transition metal, which indicates to us that if it's group 1 or cal strong bear, it's always going to be the conjugate of a strong base, which means that this is going to be such a pathetic acid. So that means that this right here, the Na portion of this, is neutral. Now let's take a look at the Br, and again, think of it as if we're putting an H in front of the Br. And is this right here a strong acid? And the answer is check mark, it is, which means that this is a pathetic base. So that means that this is also neutral, and so then both of these are neutral. So if I were to recap here, the takeaway would be if you ever have any of the transition metals as your first thing, then you're going to know that that's a weak acid. And then you're always on the lookout for things that are conjugates of strong acids and strong bases, because those conjugates are going to be neutral. Hopefully this has been helpful.